Suppose we want to store 5 integers in Java. Well, we can use variables like int I1 equals 0, int I2 equals 0, int I3 equals 0, all the way up to I5. Now, what if we wanted to instead store 10 integers? We would need to make 5 more variables. And what if we wanted to store, 100 integers? Then we would have to do something like make 100 variables like that, which would take up 100 lines of code, and no one wants to type that out. This is where something called an array can be useful. The way you make an array is first the type of the array, and then square brackets, and then the name, and then new, and then the type again, and the brackets, and then inside the brackets the size. So let's say we wanted 5 integers, then it would be like that. And now what this array would look like would be 0, 0, 0, 0, 0, basically 5 elements like that. And there's 0 because we haven't initialized them yet. And we can also access these elements through indices. So indices, and watch out, indices start from 0. So this element is at index 0. This element is at index 1. That's 2. That's 3. And that's 4. So therefore, if we did something like ARR1, and the way we access the element is inside the square brackets, the index. So if we do ARR1 of 3 equals 5, now all of a sudden the elements here, we look at index 3, and that thing is now 5. ARR1 of 2 equals 4. Now that thing is 4. ARR1 of 0 equals 2. And now that element is 2. And of course we can't access negative indices. If we try that, then when we run it, it would cause an error saying that the array index is out of bounds. We can't have negative indices. And similarly, we can't have indices that are too high. So for example, AR1 of 5 equals 0. That wouldn't work because this array only has 5 elements, which means its maximum index is 4. So there is no element at index 5. And we can also see what these elements are by printing them. So if we put these in a print statement, the first one would be 0 and the second one would be 4, as shown below. And notice how these elements of the array act exactly like variables in that we can assign them and we can also print them or access them in any other way. In fact, we can even do stuff like ARR1 of 1 plus plus, and now the element at index 1 would be 1, as shown below. Now suppose we want to print the array. If we just did system.out.println ARR1, unfortunately, it'll give some useless information right here. So we don't want to print arrays directly. Instead, we want to print their elements. In this case, I could just use 5 print statements, but if the array had length 100, I wouldn't want to use 100 print statements to print all the elements. So therefore, I can use a loop. I'll use a for loop because I can make the loop variable the index going from 0 all the way up to 4, so less than 5 or less than or equal to 4. Because remember that an array of length 5 has only indices up to 4. And then we just do system.out.println arr1 vi. And now it prints the elements 21450, which is exactly what we wanted. And actually, suppose that we don't want to hard code this. What do we want to do instead if like the array were of arbitrary length? Well, thankfully, arrays have a property called length, and we can access them using the array name.length. So arr1.length, and that in this case will just print 5. So therefore, we can do for int I equals 0, I is less than arr1.length, I plus plus system.out.println arr1 of I. And this is actually particularly useful if we want to like somehow change the array. Like say now I want this array to be of length 7. The first way would just print 21450. However, the second way would print 2145000, which is including the 2 additional elements we just added. You can also initialize arrays by listing out elements directly, like the following. If we do, say arr2 equals new int brackets, and then outside of the brackets, curly brackets, and inside the curly brackets, the elements. So let's say 5763104. And now, if we were to just print the elements of the array, it would be exactly the elements we just listed out, as shown below. And the advantage of doing this way is that if we know the specific elements and we only want like a specific instance of an array, then we might want to use this method. However, if there's certain elements that we don't know, or if the size is like huge, like 100 elements, then we want to use the other initialization method. Here's an exercise. Create an array that contains the integers from 0 to 100 inclusive. So for this one, we need to contain the integers from 0 to 100 inclusive, which is 101 integers. So we need to make an array of length 101. And then afterward, we need to populate it. It would take forever for me to just do 100 assigning statements. So instead, I'll just use a loop. And then afterward, arr3 of I equals I. And that way the element at index 0 would have value 0, and all the way until the element at index 100, which would have value 100, which would make an array that contains the integers from 0 to 100 inclusive. We can also create arrays of other types. So for example, double, or Boolean, or string, Now, what happens to non-initialized elements? For all numerical primitive data types, so for example, int, long, short, byte, double, float, the default value is 0. So basically, any uninitialized elements in an array of any of these types would be 0. For Boolean, it's false. For char, it's technically in int form it would be 0, but it's not the character 0. We don't need to worry about the default value for char. Some unusable character. And then for string, it's null, which basically means you shouldn't really tamper with anything that's null. Here's an exercise. Determine the output of the following. So for this one, we go from 0 all the way up to, 4, which is because it's 5 minus 1. And then we check out the elements of ARR8 of I. So basically what we're doing is printing ARR8 of 0, of 1, of 2, of 3, and of 4. And we notice that ARR8 really only has 4 elements, so the maximum index is 3. So actually, the output of this thing would be an error, an array index out of bounds exception. And that's what happens when we loop through the elements of an array, but then use the indices of, say, another array. And here's another exercise. So in this one, we have from 0 all the way up to 3, because less than 4, and then print ARR10 of ARR9 of I. So let's do this. So first of all, we have I equals 0, and then when I equals 0, how do we determine the output of this thing? Well, we need to know what this thing is. In order to know what ARR10 of ARR9 of I is, we need to know what ARR9 of I is. And we know that I is 0, so ARR9 of I would be 1. And then, since ARR9 of I is 1, ARR10 of 1 would be 3. And then ARR9 of I when I is 1 would be 3. So then ARR10 of ARR9 of I would be ARR10 of 3, which is 7. And then when I is 2, ARR9 of I is 5. And then ARR10 of 5, 0, 1, 2, 3, 4, 5, so that's 11. And then when I is 3, ARR9 of I is 7, so then 0, 1, 2, 3, 4, 5, 6, 7, and it would print 15. And then I becomes 4 and ARR9 dot length is reached, so then we're done. Now during these two exercises, you may have noticed that this initialization of the array was actually slightly different from our listing of the elements right here, where we needed this portion, the new, and then the array type. And here we didn't use that. In general, if we're declaring and initializing an array in the same statement, then we don't need it. Like that would work. However, if we are declaring and initializing in a different statement, so for example, like that, then that would not work. We would need the type. Similarly, if we wanted to reassign ARR11, that wouldn't work either because it's ambiguous. We don't know what type this array is. For all we know, 4, 5, and 6 could be byte, it could be short, it could be int, it could be long, it could even be double because int can be converted to double. So we don't know that, so therefore we need to specify the type here. The reason we don't need to specify the type when we're declaring the array and initializing it is because the type is already specified in the same statement. Here's another exercise. So for this one, first we'll keep track of array. That is, so first initially at line 91 where it's initialized, it's 0, 0, 0, 0. Then array of 0 is 5.7, so we make that update. Array of 2 is 7.2, so we make that update. Array of 1 is 6.8, make that update. Array of 3 is 8.0. And now, when we go through the loop, we have first I equals 0, then it prints array of I, which is 5.7, and then a space, and then array 2 of int of array of I. So array of I is 5.7, so int of that is 5. So then array 2 of 5 would be 0, 1, 2, 3, 4, 5. It would be F. And then next I is 1. Then we print 6.8, and notice we're still on the same line. And then space, and then 0, 1, 2, 3, 4, 5, 6. So G. 7.2, and then again this would be 7, so then H, and then 8.0 space I, and then a new line, and the output's shown below. Finally, another way to loop through an array is to use an enhanced for loop. So for this one, let's just say int array 3 equals 7890. We can do for every int in the array, and then do whatever we want. So for example, print it, and that would print 7890 as shown below. In general, the way this loop works is for every element, so first the way you do it is you must have the type of the variable just like a normal for loop. However, you don't initialize it, you just put a colon and then the array name. And what this says is for every element in the array, and notice the difference between these two is that here in this loop, I is an index, and it's used to access the elements of the arrays. But here, I is the element of the array. So I can directly print I instead of here, array I.